Hey, it's Mr. Luneski here, and it is Unit 10, Section 1. Unit 10 is all about circles. We're going to talk all kinds of things about circles. Today, though, we are focusing on some vocabulary. As a reminder to all students that we will be having daily quizzes for every single section in this unit. So that is a total of 5 quizzes. Also, I would like to add that this is the last big unit of the school year, that everything else after this is pretty short and sweet, and so get ready, we're kind of getting close to the end here. So, here we go with some vocab. What I would like you to do right now is just pause the video and go ahead and copy all of this stuff down. Awesome, now that you've done that, I'm going to kind of just talk to you briefly about this vocab. So, we are all talking about circles. A center of a circle is a point on the circle in which all points on the circle are equidistant, meaning it's the same length from any point on the circle to that center. It all has the same length. So in this example here, we sort of denote this as center A. The radius is the segment in a circle with endpoints as the center and any point on the circle. So a radius has an endpoint that's the center and any point on the circle. So we could say that AB is an example of a radius. We could say AE. We can say AD. Those are all examples of a radius, or radii, the plural. A chord. A chord is a segment in a circle with both endpoints on the circle. So it doesn't have to go through the center. It can, but it doesn't have to. So CD is an example of a chord because both of its endpoints are on the circle. A diameter is a special type of chord that goes through the center of the circle. I may want to remind you, you may remember this equation from back in elementary school, but the diameter is equal to 2 times the radius. So an example of a diameter here would be ED. So remember, ED is a chord, but more specifically it's a diameter. A secant is a line that goes through a circle at 2 points. So I want to specify here that it's a line, so it goes through the circle at 2 points. And so that down here in this example would be line JK. Whoops. And I want to remind you about the difference between this and this. This is line JK, this is segment JK. Segment JK is an example of a chord, line JK is an example of a secant. So just make sure that you are careful with how you note these things. The arrows indicate a line, and then with no arrows indicates a segment. And a tangent is a line through a circle at exactly 1 point, so that would be line LM. And then the point L here, that is called the point of tangency. So wherever that line touches the circle, it touches it at one spot. That one particular spot is called the point of tangency. So that's all of our vocabulary for circles. And so continuing with circles, we can look at how do circles intersect. Circles can intersect in 3 different ways. They can intersect at 2 points. They can intersect at 1 point. Or they can intersect at no points. So intersecting at no points can kind of have 2 different ways. They can just be far away from each other, or they can be one circle inside of another one. So those are the 3 ways that circles can intersect. A line, ray, or segment that is tangent to 2 coplanar circles is called a common tangent. So that means if I draw a line and it touches one circle and another circle at 1 point exactly, I can say that that is a common tangent. And so when I have 2 circles that are sort of far away from each other that aren't intersecting, I can draw 4 common tangents. So all 4 of those lines would be common tangents. If I have 2 circles that are touching at 1 point, I can draw 3 common tangents, and so that would look something like this. And so I could say that that's 3. And then if I have two circles that don't intersect each other at all, that would actually have no common tangents. So there's no way for me to draw a line that's tangent to one circle and also tangent to the other. So notice this becomes a secant on the outer circle, but a tangent on the inner circle. So that one just doesn't have a common tangent. Looking now at some properties of circles, that if I have a line that is tangent, if and only if the line is perpendicular to the radius of the circle. So I can say that this thing is tangent if I know that this is perpendicular. Or if I tell you that this line is tangent, you can then assume that the radius meets at the line at a 90-degree angle. Tangent segments from a common external point are congruent. So if I draw a tangent and draw a tangent both to a common point, I can say that these are equal to each other. Sometimes I may refer to this as the ice cream cone. So in the ice cream cone problem, you can say that the two parts of the cone end up equaling each other. Here's a quick example problem. Given in a diagram that PT is a radius of circle P, is ST tangent to circle P? In other words, I want to know, is this a tangent line? So if this in fact is a tangent line, I would know that this thing here is 90 degrees. And so now how do I check, is that 90 degrees? Well, one way I can do that is by checking Pythagorean theorem. So you may recall back from unit 8, I believe, is to check to see if something is a right triangle. You just check Pythagorean theorem, and if these two equal each other, I can comfortably say it's a right angle. So this ends up being 1,369. This also ends up being 1,369. So yes, I can say that ST is tangent to circle P. You may hear me refer to this type of problem as a pizza cutter problem. It kind of looks like a little pizza slicer, like here's the wheel and the handle. So if you see those little pizza cutter problems, chances are you're going to end up setting Pythagorean theorem up. Okay, the last little part of this is the standard equation of a circle. So the first part of the notes say to write a standard equation of a circle with a center at 0, 8, and a radius of 5. Well, it sure helps if we know what the equation is. So the equation of a circle, or the standard equation of a circle, is x minus h plus y minus k squared equals r squared. So it almost looks like the distance formula. So on something like this, hk is referring to the center of the circle, and r is referring to the radius. So in this example problem here, where I say write the equation of the circle with the center at 0, 8, all we're doing is substituting this in for h and k, and a radius of 5, substitute a 5 in for r, and simplify. So this becomes x minus 0 squared plus y minus 8 squared equals 5 squared. X minus 0 is just x, so I can actually simplify that a little bit. Y minus 8, I don't need to simplify that. I can just leave that as is, and then 5 squared becomes 25. So this would be the simplified version of our equation of a circle. The next example says to write the equation of the circle given the graph. So on the graph, you essentially are looking for the center, and then you're going to count the radius. Now you may not get the center immediately. You may not get it on the first try, and that's okay. But the idea is when you count the radius, you should have the same distance in 4 directions. So I'm going to say that the center looks to be about there. So now how do I know if I'm right? I'm going to count the radius by going right, left, up, and down. And it should be the same distance for all 4 of those because the center is equidistant to all of those points. So I go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Awesome. So that's good. So my center is at the point -5, 2. And I counted the radius. The radius was equal to 4. And so now it's just a matter of substituting that stuff into our equation. Again, this is hk. So this equation becomes x plus 5 squared plus y minus 2 squared equals 16. So remember that 16 comes from r squared, 4 squared. One thing I want to point out to you is that the points that are given to you, when you put it into the equation, it kind of looks to be the opposite of what is actually happening. So negative 5 sort of looks like positive 5, positive 2 looks like negative 2. If you take a look up here, positive 8 looked like negative 8. So it's almost sort of the opposite of what it looks like. So the equation of the circle is x minus 1 squared plus y plus 3 squared equals 9, and now I want to graph the circle. So our center, remember we sort of do the opposite. So the center is going to be at 1 comma negative 3. So I go over to 1, I go down to negative 3. That's going to be the center of my circle. And now I want to count the radius. One thing that you need to be careful about, though, is that this number 9 is not the radius. Remember, it's r squared. So if r squared equals 9, when I square root that, I would say r equals 3. So the radius is 3, so we go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So make those sort of 4 points there, and again, just go around in a circle to the best of your ability. It might not look perfect, but that's okay. Nobody's perfect. So we make a little circle there. Okay, and then the very last question that we have here, it says that the point 3, 4, the point 3, 4 is on the circle, whose center is at 1, 4, right? The standard equation of the circle. So what we have to do here essentially is solve for r, because we don't know what r is. The point on the circle is xy, and then the center is hk. So this becomes 3 minus 1 squared plus 4 minus 4 squared equals r squared. From here we simplify. 3 minus 1 is 2. 4 minus 4 is 0. 2 squared is 4. 0 squared is 0. So now we have r squared equals 0. From here, we actually don't have to solve for r. Because we're writing the standard equation, we just have to substitute in for r squared. So we can actually leave this as 4. And so then our final answer is going to be x minus 1 squared plus y minus 4 squared equals 4. So you may be asking yourself, well, why are we putting x and y back in? Anytime they ask for a standard equation, like if you take a look at the example up here, notice I had x and y. Up here, x and y are given. So anytime we give you that problem where it's a point and a center, you have to sort of remove the point from it at the end and leave the center there. So that would be our standard equation. Awesome. That is it for the video. Thank you for watching.